Hey, good afternoon or good morning, whenever you're looking at this. We're going to start the lesson today with a couple of warm-up questions over two-step equations. So go ahead and pause the video at this point, work through those two warm-up questions, and we'll be back to take a look at our answers. And we're back. Okay, let's take a look at what we got for answers here. So on the first one, asks, what is the solution to 5b plus 6 equals 21? You should get b equals to 3. And in the second one, where we have the rational expression on the left-hand side, your answer for x is 58. If you didn't get those answers, try and work backwards to find that solution, figure out how we got to here. If you have trouble with that, bring them into class, and we'll discuss it and help you out. Okay, moving on, let's look at what we're going to do today, which is solving multi-step equations. Really no new tools here. Same objective. We want to solve the equation that is in one variable, and we'll just start it with an example. Okay? If you remember, last week we talked about terms and combining like terms. So if you notice here, we want to combine those like terms that are on the left-hand side first. And I may have told you, I like to circle the terms. Remember, I'm going to include the sign with them. So if I combine the 8x and the negative 6x, 8 minus 6 gives us a 2x. Now we're down to a simple two-step equation like we've done in the past. So to simplify this, the first step we're going to take, we are going to subtract the 5 from both sides. That allows this term right here to go to 0 on the left, and we'll take it away also from the right, just like we would on a balance. So if we do that, we end up with 2x on the left, 20 on the right. We have one step left to finish. Right here you'll notice 2x, that means multiply 2 times x. So we want to undo that. To undo multiplying by 2, well, we're going to divide. Okay? And you notice here, 2 divided by 2, that's just 1. 20 divided by 2, we're going to get 10. So with that answer, you can always take that answer if you want to make sure that it's right, and you can go back to the original equation, substitute it into the places where the x's are, and see if you get it to equal what's on the right-hand side. Okay, let's apply that in a little bit more of a real-world type of situation. And you guys know I like going to movies, so I had to throw a movie one in here. We have Jason here, and he bought 5 movie tickets and a bag of popcorn. His friend Jeremy bought 2 movie tickets, and together they spent $54. If the popcorn is $5, how much did they each spend? So let's set this up as an equation first. So look at the first sentence here. We have Jason's portion, the 5 movie tickets, and we're going to replace movie tickets with the variable m, because we don't know their price, but we know we bought 5 of those. And his bag of popcorn, we'll use the letter P for that variable. For Jeremy's portion, he has 2 movie tickets. Okay, so we just added on to what Jason purchased, and we know that together they spent $54. Okay, so in our next sentence, we notice right here something that's going to help us out, which is that the popcorn is $5. So what we'll do is we'll take this $5 and we are going to substitute it in for that variable. And we end up with $5 there. Okay, so this looks a little similar to that very last example we did. We need to combine terms. Ones are like the 5m, the 2m. If we do that, we end up with 7m. 7 movie tickets plus the $5 popcorn. And if we subtract the $5 from both sides, we eliminate it from the left. We eliminate it from the right, so 54 minus $5. Just show that here. Okay, gives us $49. So 7 movie tickets are going to cost the boys $49. So we want to know what's the cost of each movie ticket. Undo this multiplication right here. Divide by 7, and oops, let's try this again. There we go. Go back up here and get my pen so I can do this. Okay, there we go. And we'll divide by $7 here. We find out that each movie ticket is $7. That's a good price for a movie ticket, by the way. Okay, so Jeremy and Jason's movie tickets are $7. Okay, there's an application right there of using some of your algebra skills to solve a little bit more of a real-world problem. So let's give you one to try on your own. This is one about Noah and Kate. Go ahead and work through this problem. Pause the video while you're working, and then we'll come back and see what things look like. Okay, so go ahead and pause your video. Okay, we're back. Let's take a look. What is this going to look like? So 1 pack of strings, we find out, is $14. So here's the work laid out for you. And you're welcome to copy this work down in your notes. Okay, compare it to what you've done and see what differences there are. If you came up with the $14 and use a slightly different method, that's fine. Just be able to explain it. Okay? Okay, let's go on to the next part of this, which is solving an equation with the distributive property. This is still considered a multi-step equation. So we want to find what is the solution for 12 times 3 minus x equals 60. Okay, so on this one I'm going to show you kind of the standard way of doing this problem, and later in the next week or so I'll show you what may be a little bit different way. Okay, so first things first here, we are going to go ahead and apply that distributive property by multiplying the 12 to every term inside of the parentheses. Just like we've done before, you notice I included the arrows there. So 12 times 3, we're going to get 36. And 12 times a negative x, you get the negative 12x, and that's equal to 60. So be thinking, how do I eliminate what's on the left-hand side where my variable is? Some of you are going to choose to try to move this 12x. I'm going to caution you there. Start here with your constant. Okay, let's subtract that constant from both sides. That's 36. And when we do that, of course, it goes away on the left, the negative 12x. There's no math to do underneath of it, so it's just going to fall down. On the right, 60 minus 36, you get the 24. Okay, so again, we have multiplication going on here, and we want to undo multiplying, so we do that by dividing. We'll divide it by the negative 12 on both sides, and when we do that, we get that x is equal to negative 2. Okay, good work. Make sure you're taking notes on this and writing down questions as we go here. Let's look at another example here. This one contains fractions, and I know how much we all love fractions, but we're going to try and make this easy on you. Okay, so the first method is going to go back a little bit to some things we've done in the past, okay, with subtracting fractions. We're going to find a common denominator, okay? So to do that, we're going to rewrite the equation using common denominators. So the first one, we're looking to get a common denominator of 8, okay? So some of you may be asking, hold on, how did you go from the 3/4 to the 6/8? Well, I know that to get a denominator of 8 in this first term, I'm going to have to multiply the bottom times 2. Well, whatever I do to the bottom, I have to do to the top, okay? Because it's just like multiplying by 1, okay? 2 divided by 2 is 1. So that's how we can do this, okay? It doesn't really change the value of the fraction. It's just changing what it looks like, okay? Now we have like denominators. We can combine those, and we end up with 5/8 times x equals 5. So to eliminate this fraction on the left, we're going to multiply by its reciprocal, which I'll show you here next. So we'll multiply it times 8 over 5, which those of you that remember cross-canceling, and we can go over that in class if we need to, cross-canceling allows me to eliminate these fractions or these numbers that are diagonal to each other, okay? Just like that. And when I do that, when I do the cross-canceling, I end up with a value for x of 8. Okay? The second method, and a method that I actually like a little bit better, is to do what's called clearing the fractions. So what we do is we still look for that least common denominator. So when I look at my denominators here, 4 and 8, the smallest denominator that's common between them is going to be 8. Okay, so if I multiply each of these fractions and this number, all of it, by 8, just like I'm doing here, okay, I will eliminate the denominator. Okay, so I'll use the distributive property. And if I multiply this first fraction by 8, you'll notice that I can cross-cancel the 4 and the 8, but there's going to be 2 left over. Okay, so watch what I'm going to do here. I cross-cancel here, right? How many 4s are in 8? There's 2 here. If I cross-cancel the 8s, they just go away. They cancel out. Okay, so now 2 times 3x, we get 6x minus the x from the second term equals 40. We'll simplify the left-hand side by combining those terms to a 5x and finish it off by dividing that 5 through, and we found out that x is equal to 8. Here's one for you to practice on your own. Go ahead and pause the video, refer back to that last example if you need to, and try to work through this one using either of the two methods that I've left you with. Okay, so let's see what our solution looks like. Aha! Your solution, 60 over 23. Now that's an improper fraction. It's not really a very friendly number. That's okay. It doesn't mean it's wrong. Okay, so again, go back through. If you did not get this answer, bring it to class with your questions, and we'll go over this one. Okay, what about decimals? There's also two methods here, although because of having the use of calculators, I'm not so sure that the second method is as useful, but let's go ahead and look through the first one. We'll just solve it like we normally would. Okay, just treat them like regular numbers using your calculator. We'll subtract the 2.3 from each side. Just remember, line up your decimals. Okay, when you do that, you end up with a negative 0.05x. Don't forget, the sign stays with the term. Okay, that's where a lot of mistakes will happen. If we subtract these two numbers, we get 2.5. Of course, the next step is going to be to divide by negative 0.05, and you'll end up with an answer of x being equal to 50. Sorry, negative 50. Okay. Second method. Okay, now this is similar to clearing the fractions a little bit. We're going to look at the number of decimal places. Okay. Notice we have 2, which tells us, I need to multiply it by a factor of 10, right? 2 factors of 10. So 2 factors of 10 is 100. So if I multiply everything by 100, we end up with whole numbers here. And for some of you, that's going to be a better way to work the problem. And that's fine. You can do that, okay? So if I do that problem, you'll notice that I end up with the same answer as what I had with the first method. Okay, good job. That's multi-step equations. Bring your questions to class on this one, and we'll work through them, and then we'll get some practice.